Hello everyone, welcome to Dakshana e-classroom program, and this is a solution video for exam MJT03 for NEET aspirant and part physics. So let's continue the discussion, and this video will help you in understanding the questions which you were not able to solve during your exam. So here we have question number 1, the capacitance C of a capacitor. So question number 1, so we know C is equal to Ka epsilon naught by D. It's option independent of charge and potential of the capacitor. That seems correct. Dependent on charge, no. Independent of geometrical configuration of the, no. Independent of electric medium between the two conducting, no. So correct answer is 1. Question number 2, an intense light source radiates uniformly in all directions at a distance of 5 meters from the source. The radiation pressure on the perfectly absorbing surface is given as, so radiation pressure is equal to I by C, that is given as 9 into 10⁻⁻6 Pascal. Now what it's asking, average power output of the source. So we can write this is pressure, actually this is not power. So we can write intensity is equal to pressure into C, and intensity is equal to power divided by area. So power is equal to pressure 9 into 10⁻⁻6 into C into area 4 pi into 5 square. Solving, substituting and solving it, we get actually power is equal to 849 kilowatt. Matching option number 3. Question number 3. For the given situation, find tension T at point P in string. Particle is moving in vertical circle. Particle is moving in vertical circle. Here, this, and this angle is given as 53 degree. This is 1 meter. So this height is equal to what? 1 cos 53, and that is equal to 3 by 5. This, and this is 37 degree. This is also 1, so this is 4 by 5. So total height from here to there, it's basically 7 by 5. Now here speed is given as 10 meter per second square. Here speed is, let's say, v. So we can write by conservation of energy, mu square by 2 equal to m v square by 2 plus mg into, this is 7 by 5, and m gets cancels. U we know already, so v root over u square minus 2g into 7 by 5. U value substituting 10, we are getting it, v is coming out to be how much? This is root 72 meter per second. We got v. Then at this point, actually, so tension T in the string, mg is acting this way, and this is 53 degree, this is also 53 degree. So we can write actually T plus mg cos 53 degree should be balancing the mv square by r. R is equal to actually 1. So here T, everything is given to mg cos 50 mv square, we already got. Substituting everything and solving, we are getting C, T is equal to 66 Newton, matching with option number, this is 2. Question number next 4. Here, keeping the banking angle of the road constant, the maximum safe speed of passing a vehicle is to be increased by 10%. The radius of the curvature of the road will have to be changed from 20. So we know actually V max is equal to RG into tan theta, right? Root over or V square. So initially, let's say V is speed is V, so then we can write V naught square is equal to R 20 into G into tan theta. Theta is remaining constant. Next V prime square, that speed is equal to 1.1 because 10 increasing by 10%. This is R prime into G into tan theta. Dividing, solving, and R prime is coming out to be basically V naught square gets cancelled. This is equal to 1.1 whole square multiplied by 20, that is 240.2 meter. Next question number 5. In a problem, the equation is given by delta lambda is equal to, this is lambda root over 2 phi psi divided by mv square into cos of theta. In this problem, psi may represent the physical quantity, so this quantity may represent, so here you can say this is lambda, this is also lambda, dimensionally both are becoming equal, this must be equal to this, so that may represent kinetic energy, velocity, momentum, force, that's matching with kinetic energy. Question number 6 next. In a damped oscillation, the amplitude after 50 oscillations is becoming 0.8 a naught, where a naught is the initial amplitude, then amplitude after 150 oscillations. So let's say time period for is t for 50 oscillations, then it will be definitely 3t for 150 oscillations. So we can write it's 0.8 a naught equal to a naught e raised to a minus something alpha constant multiplied by t. Next it's becoming some a equal to a naught minus 3 alpha t. From here a naught gets cancelled. I can write the substitute the value of minus alpha t. So a is equal to a naught into this is 0.8 power 3. Solving we are getting a is equal to 0.512 a naught. This is the answer matching with option number 1. Question number 7. Pure inductance of 3 Henry is connected as shown in the figure. The equivalent inductance of the circuit. So here we can see it all are in parallel. So 1 by L equivalent is equal to 1 by L1 plus 1 by L2 plus 1 by L3. Simplifying it, L equivalent is equal to 1 Henry. So next question number 8. Here it matches with option number 1. Question number 8. A plumb line is suspended from the ceiling of the car moving with the horizontal acceleration a. What will be the angle of inclination with the vertical? So plumb line, so it's basically like this, so originally, but because of acceleration it will be like ma, here it's mg, this angle theta, this will be theta, so we can write tan theta is equal to ma by mg and theta is equal to tan inverse of a by g. That's matching with option number 1. Next question number 9. Capacitor of capacitance C has initial charge Q0 and connected to an inductor L as shown in a figure. At t is equal to 0, switch is power. Press the current through the inductor when the energy in the capacitor is 3 times of the energy of the inductor. So means total energy is Q0 square by 2C, energy Q square by 2C in capacitor plus half Li square, and now it's given as current through the inductor when energy in the capacitor is 3 times of energy of inductor. So this is equal to 3 times of this, so that's equal to 4 into half. This is basically 3 by 2 Li square plus Li square by 2. It's basically 4, so it's 2. Then this implies I is equal to Q0 by 2 root LC. That will be the current. That's matching with option number 1. Question number 10. In LCR circuit, capacitance is changed from C to C. For the resonance frequency to remain unchanged, inductance should be changed from, so resonance frequency 1 by root over LC. So now if C is made twice, then L must be made half, so it should be L by 2. That's matching with option number 3. Question number 11. Two particles of masses m1 and m2 are projected from the top of the tower. The particle m1 is projected vertically downward with the speed u, and particle m2 is projected horizontally with same speed. The acceleration of center of mass of the system is neglect air resistance. So acceleration of each particle is simply g, so acceleration of center of mass will be also simply equal to g downward. That's matching with option number 1. Question number 12. If thin mica sheet of thickness t and refractive index mu 5 by 3 is placed in front of the path of the interfering beam as shown in the figure, the displacement of the fringe system, so that's equal to d sine theta minus mu minus 1 into t, and this is dy by capital D equal to mu minus 1 into t. Substituting mu will go to 5 by 3, and y is the displacement, that's equal to 5 by 3, it's 2t capital D by 3 small d. This will be the displacement. That's matching with option number 3D, matching with option number 2. Question number 13. Ratio of intensity of two wave is 25 by 36. If interference occurs, then ratio of maximum and minimum intensity. So I max by I minimum. This is equal to root over I1 plus root I2 whole square, root I1 plus root I2 minus whole square. Substituting 25, 36 and solving this, we get it's 121:1, matching with option number 4. Next, question number 14. A flow speed of air on the lower and upper surface of the wing of aeroplane are V and root 2V, lower V and upper 2V, root 2V respectively. Density of the air is rho, then surface area of the wing is A, dynamic lift of the wing. So we can apply Bernoulli's principle between A, lower and upper surface. So it's P1 plus half rho V1 square V square, P2 plus half rho into root 2V, that is 2V square. So here pressure will be low, so P1 minus P2 can be written as this is basically 2 minus 1, so it's rho V square by 2. Pressure difference multiplied by area multiplied by A will be the lift, and that's matching with option number 3. Next, question number 15. So here uniform cube is subjected to volume compression if each side is decreased by 1%, then the volume of the volume strain. So V is equal to A cube, taking log delta V by V is equal to 3 times delta A by A, and this is 1%, so this is equal to 3%, matching with option number 4. So volume strain 3%, and that will be equal to 0.03. In percentage it will be 3%. Question number 16. Stretched wire emit a fundamental frequency note of 256 Hz, keeping the keeping the stretching force constant and reducing the length of the wire by 10 cm. The fundamental frequency become 320 Hz, the original length. So fundamental frequency F0 is equal to 256 equal to V by, so because remaining things are constant, root over 2, this is L, and next case it's 320 equal to V by 2 L minus 10. So this is two equations, dividing and simplifying and solving it, we are getting L is equal to 50 centimeter. Question number 17. Body is projected vertically upward from the surface of the earth, so means projected, so initial velocity must be higher and positive, then it must be decreasing. Speed time graph, so maximum velocity decreasing, then velocity it will become negative, but because it's asking speed, so it will be like this. So that will match with option number 3. Answer given is 2, that will be a wrong answer, so correct answer will be 3. Question number 18. Engine of the train passes an electric pole with a speed u, and the last component of the train passes the same pole with a speed with a velocity v. Then find the velocity with which the midpoint of the, so it's just simply equal to basically like initial velocity when first engine is passing is u, final velocity, so by the time it's covering a distance of how much, equal to the length of the train's length of the train is, let's say 2L, then I can write v square minus u square is equal to 2a into L is 2L. In next case, let's say velocity is v prime when its L distance is covered, means midpoint is passing, so v prime square minus u square is equal to 2a into length L. Just simply dividing and solving it, we are getting v1 prime is equal to, this is root over v square plus u square by 2. This is the answers. We can simply getting solve it and getting it matching with option number 3. Question number 19. Figure below shows regular hexagon with charge at the vertices. In which of the following cases electric field at the center is not 0? So in one case we can see the electric field due to each opposite charge will cancel out, so it will be 0. In two cases it will be like, we can just check it, so horizontally it will cancel out, and these two diagonal cross, is it? Here this charge and this charge is minus q plus q plus q plus q plus q, cancel out, not cancelling, not cancelling, so it will be non-zero here. That's matching with option number 2. Next, question number 20, and before that let me erase the board. Okay, so next question number 20. The three charges plus 4q, q and small q are placed in straight line at a line of length L at distance 0, L by 2, L respectively, where what should be the q in order to make the net force on small q to be 0? Question number 20. So your charges are, here it's 4q, this is q, and this is small q, this is 0, L by 2, L. Net force here must be 0, so same charge, force will be repulsive, it must be opposite, then only it's possible Fq, F4q on this. So we can write net force must be like 0, K q square 4 divided by L square plus I can add K q by L square into 4. So 4k L square gets cancelled, 1 q. This implies capital Q is equal to minus q, and that's matching with option number 1. Question number 21. A particle of mass capital M is at the center of the spherical shell of same mass and radius a. Gravitational potential at a point situated at a by 2 distance from the center will be. So here this is M mass, radius a, center M mass, potential at distance a by 2. Due to spherical shell it's minus g m by a. Due to this it will be minus g m by a by 2, means 2. So this is net potential is minus 3 g m by a. This which is matching with option number 1. Question number 22. Weight of an object on Earth's surface is 200 kg. Find out its weight on the surface of planet having mass 1 by 4 times of the Earth and radius of the Earth. So we need to calculate the value of g is equal to root over g m by r square. Mass g prime, g mass is m by 4. Radius is how much? Half, so it's r square into 4, so it's basically same g, so same mass, weight will be also same, so 200 kg, matching with option number 2. Question number 23. Alright, in the following figure the velocities are in ground frame and cylinder is performing pure rolling motion on the Planck. Velocity of the point A would be, so in this case we can write for point, this is the C, A, B, this is Planck, V, P, this is VC, A, angular velocity omega. So we can write for this point, because of pure rolling condition, VC minus R omega must be equal to VP. This implies R omega is equal to VC minus VP. Velocity of point A is equal to VC plus R omega. R omega is equal to this is coming out to be 2VC minus VP. This is the answer, matching with option number 3. Next, question number 24. So particle of mass m is thrown with a speed v0 at an angle 30 degree with the horizontal. The angular momentum about the point of projection when the particle is at highest point of the trajectory. In this case, this is the situation. It's projected with some speed u, angle theta at the point of highest point. Its velocity is m u0 cos theta. So the angular momentum about point of projection, this is h max. L is given by m u0 cos theta multiplied by h max. Substituting and solving, we are getting L is equal to root 3 m v0 cube by root 3 m v0 cube by 16. This is the answer, substituting and solving, matching with option number 4. Question number 25. So two identical glass mu0 3 by 2 equiconvex lens of focal length f are kept in contact. The space between the two lenses is filled with the water, mu water 4 by 3. The focal length of the combination is, तो यहाँ पे हैं दो lens like this, and mu is equal to 3 by 2. Focal length f, so radius I can write 1 by f is equal to 3 by 2 minus 1 into 2 by r, and this implies 1 by r. So focal length is equal to r, radius of curvature. This lens filled with water, 1 by f water lens will be equal to 4 by 3 mu minus 1. This is minus 2 by r. Solving it, it's coming out to be minus 2 by 3 r will be the focal length of water. So 1 by f water is equal to minus 3 f by 2, because F is equal to R, so F equivalent is equal to 1 by F plus 1 by F minus 2 by 3F. This implies taking LCM 3F, 6 minus 2. This is coming out to be 4. So F equivalent is equal to 3F by 4, which is matching with option number 4. Question number 26. So here, for a glass prism, mu is given by as root 3. Angle of minimum deviation is equal to angle of the prism. Angle of the prism. So mu equal to root 3 equal to a sine of delta minimum and a are same. So this is 2a by 2 sine of a by 2. This is sine a. It can be like 2 sine a by 2 cos a by 2. This is sine a by 2. Cancel. So root 3 by 2 cos a by 2. So a by 2 is equal to 30 degree. A is equal to 60 degree is the answer, matching with option number 4. Question number 27. Concave mirror forms image of an object such that distance between the object and image is 60 centimeter and the magnification produced is 1/4 focal length of the mirror. So here let's say this is a mirror, this is X, this is object, here it's image, 60 minus X, magnification is 1/4. This is equal to V, 60 minus X divided by X minus V by U. So, or minus X. Solving it, this implies minus X, 240 minus 4X, 3X, X is coming out to be right. So, 24. It is a magnification should be not negative. This implies X is 48 centimeter. Now we can substitute it here. So 1 by V, that is 48 positive, minus this is minus 1 by 12 equal to 1 by F. Solving it, we are getting F is equal to 16 centimeter. F equal to 16 centimeter. This is the answer, matching with option number 4. Question number 28. So here electron proton enter region of uniform magnetic field in a direction at a right angle to the field with the same kinetic energy. They describe circular paths of radius RE and RP respectively. Then so radius is equal to mv by qb. This is the same kinetic energy, so root over 2 km by qb. So for electron mass and charge, proton charge is same, B is same, so it's directly proportional to mass. So mass means RP is greater than RE because mass of the proton is greater. So that's matching with option number 2. Question number 29. Here find magnetic field at O. So this and this. Here this is the system. This how many are there? 3 only. Okay, it's not this one and this is R, 2R, and this is 3R, angle theta. So due to this, let's say magnetic field is inward, due to this it will be outward, and due to this also inward. So net magnetic field is mu naught into I into theta divided by 4 pi into 3R plus, let me add both inward, so plus mu naught into I theta divided by 4 pi into R minus mu naught into I into theta divided by 4 pi into 2R. This, solving it, we are getting B is equal to 5 mu naught into I theta divided by 24 pi into R. This is the answer, matching with option number 1. Question number 30 next. So in the following circuit, value of Y. So here also 3 diode gates are given. This here this, this, so it's 1 0 1 inverse of this 0 0 0, it will be 0 inverse of that 1, it's 1, it's 1 1 0, it's basically like and so it will be like 0 inverse of that, it will be like 1, and it's 1 farad here, and 0 inverse of that 1 1 1, it will be 1 and 0, so output y is equal to 0. That's matching with option number 1. So up to question number 30. Next question number 31. Let me erase the board again. So okay, so next question number 31. It's based on Zener diode. A Zener diode having breakdown voltage of 15 volt used in a voltage regulator circuit shown in the figure. The current through the Zener diode is. So it's a good problem actually. This is Zener diode, and resistance 1 kilo ohm. This is 250 ohm plus minus 20 voltage. This is, so 20 voltage, it's 15 voltage, 5 voltage current here. I can be written as 5 divided by 250, that's equal to basically 20 milliampere. Now 15 voltage will be also across this, so let's say it's I1. So I1 can be written as basically 15 divided by 1 kilo ohm, that means 15 milliampere. The current must be here 5 milliampere. That's matching with option number 1. Question number 32. So here a semiconductor X is made by doping a germanium crystal. Germanium crystal, that means 32 atomic number, with arsenic Z equal to 33. So it's basically a semiconductor, then it's basically n-type because pentavalent more, and indium, that is Z equal to 49, so it must be basic, it is actually p-type. So now the two, okay, so X is made by doping germanium crystal with arsenic, so X with arsenic, this is p-type, and Y it's basically this is n-type and Y is p-type. This is the system. The two are joined end to end and connected to a battery as shown in the figure. Which of the following statement is correct? So X and connected to positive, so means it's reverse bias. So X is n-type, Y is p-type, and junction is reverse bias. 4 is the correct answer. Next question number 33. In the circuit shown, the current through 8 ohm is same before and after connecting battery E, the value of E. So here, like, let's write the current initially, that will be equal to 12 divided by how much? This is 24, that is 0.5 ampere. Even after also the current is same, so that means the E must be equal to how much? This is 8 multiplied by 0.5, that is 4 volts. If potential difference across 8 ohm resistor is equal to the EMF, no current will be additionally flown because of battery, so that is possible then when E is equal to 4 volt, matching with option number 3. Question number 34. So here the equivalent resistance between A and H of the cube if resistance of each side is 1 ohm. So here this is the circuit, this, and here you are asked to find between opposite corner. Let's say this is A and H, whatever it is. Between every two junction there is one resistance. So here you can see, let's say A, B, C, D. This is E, F. Okay. All right. Let's say G and H. So now you can see here this. Okay, it's E, F, G, H. All right, E, F, G, H. So E, this and this, this all same potential, and now from here we can say this, and this will be in same potential. So we can connect all these points, and now so it will be like A point, this is H, this is A connected to, this is D, F and C. So DFC, so 3 in parallel, so it will be basically R by 3. Similarly here it will be G, E, C, G, E, here it will be not C, it will be B, E, C. So here also 3, R by 3, and 6 will be here in parallel, so R by 6. Simply R equivalent all in series. Solving it, R equivalent comes out to be 5R by 6. This is the answer matching with option number 1. Oh. Next, question number 35. In a wire of cross-section radius R, free electron travel with the drift velocity V when a current flow through the wire. What is the current in another wire of half the radius and same material when the drift velocity is 2a? So I is equal to NEAVD, drift velocity. N is the number of like charge carrier per unit volume. It's a property of the material. So same materials means N is same. So I, next I prime, N, E same. I current radius is half the radius, so it's A by 4 into drift speed 2V D. Simplifying it, NEAVD, this VD, so it's basically 2. So I prime is equal to I by 2 will be the answer, matching with option number 3. Question number 36. A Carnot engine works between source of temperature 27 degree and minus 123 degree. Its efficiency, so eta of Carnot is equal to 1 minus T2 by T1. This is 1 minus T2 is 173. It's 150 divided by 300, that is equal to 50% or 0.5. So that's matching with option number 1. Question number 37. Which of the following graph correctly represent the variation of beta is equal to minus dV by dP 1 by V? Actually this is equal to 1 by P. So beta versus P graph, it is a rectangular hyperbola like this, matching with option number 1. Question number 38. Here the RMS speed of the group 7 gas molecule having speeds this is, so VRMS is equal to root over root mean of 7 of square 6 square plus 4 square plus 2 square plus 0 square, minus 2 square will be also 2 square, minus 4 square will be also 4 square, plus 6 square. Solving it, we are getting it 4 meter per second is the RMS speed, matching with option number 4. Question number 39. So here black body is at temperature of 5760 Kelvin. The energy radiation emitted by the body at wavelength 250 nanometer is U1, wavelength 500 nanometer U2, and 1000 nanometer is U3. Ven's displacement B is equal to 2.88 into 10 to the power 6 nanometer Kelvin. Which of the following is correct? So first thing is temperature is 5760 Kelvin. By Ven's displacement law, B is equal to lambda into T, because lambda is inversely proportional to temperature, or temperature is, so this, and here substituting 5760, B is equal to 2.88 into 10 to the power 6. Solving it, we are getting lambda is equal to this is equal to 500 nanometer, means the radiation emitted will be maximum for 500 nanometer. So for the remaining it will be less than this. So U1 equal to 0, definitely not. U3 equal to 0, not. U1 greater than U2, not. U2 greater than U1, that will be the correct option, because this will have maximum, so means U2 will be maximum. Next, question number 40. When water is heated from 0 to 10 degrees Celsius, it's so at 4 degrees Celsius its density is basically maximum. So when it's heated from 0 to 4 degrees Celsius, it basically contract. Heated from 4 to 10 degrees Celsius, it will expand. So heated from 0 to 4 degrees Celsius, its volume first will decrease and then increase. 4-1 will be correct answer. Next question number 41. Half-life of radioactive isotope is X is 25 years. It decayed to another element Y which is stable. The two elements X and Y were found to be in the ratio of 1:15 in a sample of given rock. The age of the rock estimated. So X to Y equal to 15, 1:15. So means X upon Y is equal to, this is 1 upon basically all right, the age of the rock was estimated to be, all right, so this total ratio means total initially was only X, now it has become 1:15. It will be like 1/16. So here we can write actually, all right, so it's equal to X upon Y equal to 1/15 X. All right, just wait a second. Half-life of radioactive isotope X is 25 years. It decayed to another element Y which is stable. The two elements X and Y were found to be in the ratio of in a sample of given rock. Okay, so means now left X is equal to originally X prime by, all right, Y decayed I can write will be equal to just wait a second. Okay, so here it's given X is to 1, Y is 15. So let me say initially, let's say the number of nuclei of X is N naught. Now it is 1 out of 15, so means out of 16 it's basically 1. So now it become N is equal to N naught by 16, which is equal to N naught by 2 power 4. So means it has taken basically 4 half-life. So time taken up to this point is equal to T equal to 4 into T half, that's equal to 100 years, because T half is 25 years. So that's matching with option number 4. Question number 42. Here, energy released in the fission of uranium-235-92 nucleus is 200 mega electron volt. The fission rate of uranium-235 fuel reactor operating at a power of 5 watt. So 5 watt is equal to number, यहाँ पे आपको पूछा गया the fission rate. So let's say fission rate is N, 200 into 10 to the minus 6 mega electron volt into 1.6 into 10 to the minus 19 and per second. So this is N solving 5 divided by 200 into 1.6 into 10 to the power minus, this is 13. Solving it, we get N is equal to 1.56 into 10 to the power plus 11 per second. This much number of radioactive nuclei must basically fission so that they can produce 5 watt of power per second. Next, 43. All right, fuel operating at a power of 5 watt. Okay, next question number, what is the ratio of area covered by first and second orbit? Okay, so first orbit and second orbit, here we know actually area is directly proportional to R square and R is directly proportional to N by Z. So basically R is directly proportional to N square by Z. So area is directly proportional to N power 4. So A1 by A2, this is equal to 1 by 2 power 4, that is 1 by 16. And that's matching with option number 3. Question number 44. De Broglie wavelength and kinetic energy of the particle is 2000 angstrom and 1 electron volt respectively. If its kinetic energy become 1 MeV, then de Broglie wavelength will become. So lambda de Broglie wavelength is equal to H by root over 2 km. All right. So initially it's given as 2000 angstrom. K is 1 electron volt. m into 1 electron volt. Next it's h by root over 2 m into 1 mega 10 to the power 6 electron volt equal to, let's say, lambda prime. Just simply substituting this gets cancelled. Root over 10 to the power 3 is 3 gets, so it will be like lambda will be 2 angstrom will be the answer, matching with option number 2. Next question number 45. So two identical photocathode receive light of frequency f1 and f2. Velocity of the photoelectron of mass m coming out are respectively v1 and v2. So we can write h f1 minus phi is equal to m v1 square by 2. H f2 minus phi is equal to m v2 square by 2. Solving it, eliminating, we are getting it v1 square minus v2 square is equal to 2h by m into f1 minus f2. This is which is matching with option number 1. So this is all about your paper MZT 03. Thank you everyone.